Alright, welcome back. So today we're going to start looking at probability, and probability is just a way of determining the likelihood of an outcome. So it can be very useful for lots of things, whether you are trying to determine whether something is safe, whether something is healthy, whether something will lead you to financial success or complete and utter ruin. But we're going to start out with a concept called the sample space. And the sample space is basically all the things that can happen within a chance experiment. And it'll make more sense as we go through it. So let's get started with our first one, 1A. List the sample space for the letters of the word book. So, if we were pulling letters out of a hat, and there were just the letters for the word book in there, what are the possible outcomes? Is basically what this is asking us. So the sample space is equal to B O O K. And realistically, all it's asking you in any sample space is what could possibly happen in this situation? What are all the possible outcomes? Now, if in that hat there are only 4 pieces of paper and each piece of paper only has 1 letter on it, then obviously the only outcomes that can happen is we draw one of those letters. Importantly, we usually assign the sample space the pronumeral or the variable s, and we usually use these curly brackets to encase all the possible outcomes, with commas between each one. Alright, let's look at B. So now we're going to see how sample space and probability are related. So find the probability that the letter O is chosen. So we write this as the probability, and in regular brackets we put down what we are looking for. So O is what we are looking for, the probability of O. Now, to determine probability, we use a very simple formula. So the probability of an event is equal to the number of favorable outcomes, and we divide that by the total number of outcomes. Okay, so just remember this, it's actually really simple. Now, it sounds difficult. What's a favorable outcome? Well, a favorable outcome is any outcome that matches what we're looking for. So we're looking for the probability of O. So our favorable outcomes are going to be these two here. So there are actually 2 favorable outcomes. And in total, we have 1, 2, 3, 4 total outcomes. So the probability of getting an O when you pull that piece of paper out of the hat is actually 2 out of 4, which is the same as a half. And if you don't know about simplifying fractions, there are some other videos you can watch, but just trust me that this fraction simplifies to a half. Right, so what's the sample space for choosing a vowel? So we know what vowels are. We know that A, E, I, O, and U. And we know that our sample space is an S. And the only 2 letters here that are vowels are going to be O. So the sample space of choosing a vowel is just O and O. So we can simplify or make our sample space smaller depending on what we're looking for. And sometimes we assign this a different variable. So we might give this the variable V, for instance. Let's look at D now. Find the probability of choosing a vowel. So the probability of a vowel is equal to, well, the number of favorable outcomes, which is 1 and 2, divided by the total number of outcomes, which again is just 4. Okay, again, this simplifies to a half. Alright, let's have a look at another one. Okay, so here's another one. In this particular question, we're going to be looking at a spinner. And if you don't know what a spinner is, think Wheel of Fortune. All it is a circle or a wheel that is divided up equally into different parts. Now for our one, it's divided up into 5 equal sections. And this is important. If it was unequal, or one was a larger area than the other, then it would have a greater chance of occurring. So if I was to make a very unequal spinner, like I have here, then obviously each one of these 3 here would have an equal chance of occurring, but these 2 would be less likely to occur because they're a smaller area of the circle. Right. So the first question asks us to find the sample space. So for A, our sample space is going to be equal to, now you can write out red, blue, green, yellow, and purple. That's totally fine. I usually just write out the letters. Now it will depend what the question asks or what your teacher wants you to do, but usually for me this is fine. Okay, find the probability of landing on green. So the probability of green. So again, probability, total, the number of favorable outcomes divided by the total number of outcomes. So we only have green as our favorable outcome. That occurs once. So our total number of favorable outcomes is 1. And our total number of outcomes is 1, 2, 3, 4, and 5. Alright, so we've done our probability. We have a 5th, 1 in 5 chance of getting green. Alright, what's the probability of landing on a primary color? So the probability of a primary color. Now if you don't know, the primary colors are red, yellow, and green. Alright, so those are our 3 favorable outcomes, red, green, and yellow. So there are 3 favorable outcomes, and again there are only 5 total outcomes. So our probability of landing on a primary color is actually quite high. Okay, what is the sample space for the complement of landing on red? Now this is a bit tricky because it's kind of worded in a very confusing way, but a complement is actually a very common thing we talk about in probability. So basically, any event like landing on red has a complement, and the complement is not landing on red. So when it's asking for the sample space of the complement of landing on red, it's asking for all the possible outcomes that are not landing on red. So if we go to our sample space, what up here is not red? Well, everything over here is not red. That means that the event is red, and everything here is the complement. So blue, green, yellow, and purple. Not purple. Right? So a complement is always the opposite, or what we're not landing on. So if I roll a dice and I get a 1, okay, the complement of getting a 1 on a 6-sided dice is getting the other 5 numbers, a 2, 3, a 4, a 5, and a 6. Alright, lastly we have E. What is the probability of not landing on red, or not red is usually how we write it. So the probability of not red is going to be basically our favorable outcomes, anything that isn't red. So 1, 2, 3, and 4, all the other colors that are not red, 4 favorable outcomes out of 5 total outcomes. So it can be confusing, and a lot of probability and some of the most challenging questions you'll find in probability have everything to do with the wording. So just be aware that that can be confusing, but just think about it differently. the event is landing on red, its complement is not landing on red. If the event is getting a 1 on a 6-sided die, the complement is not getting a 1. Alright, that's it for this video. Hopefully it was helpful, and I will see you in the next one.